In this video, we'll be looking at improper integrals. So we're going to start by evaluating the integral 1 divided by x cubed from 1 to infinity. Now, since infinity is just an idea or concept, we can't just integrate as usual and then plug in the infinity to get an answer. What we need to do is we need to think of this as an area problem. So we need to focus on finding the area over the integral 1t where t tends to infinity. Now, to solve this problem, what we do is we substitute, so we replace our infinity with the variable t. Now, the infinity is the point that is giving us some problem, so that's our problem point. So replace the infinity with t, and we take the limit as t tends to infinity. Now, if you remember, or if you recall from previous calculus courses, if we were to apply the substitution method to evaluate this limit, then we just substitute t as infinity, and this problem would just be the one that we started with. So what we do now is we integrate this guy here. So we integrate 1 over x cubed from 1 to t, and that gives us negative 1 over 2x squared, and we have our boundaries, so from 1 to t. Now we know how to address this from previous calculus courses, or we substitute the upper bound, so we substitute t in for x minus we substitute 1 for x, and that would give us the limit as t tends to infinity of a half minus 1 over 2t squared. Now applying our limits, so substituting t for infinity gives us a half minus 1 over 2 times infinity squared. Now 2 times infinity squared, that's just infinity. 1 divided by infinity, that is 0. So we just have a half minus 0, and this is just a half. So the value of this integral is a half. And the fact that this is finite, it means that the integral converges. So whenever the value is finite, we say that the integral converges, and it converges to that value. So this integral would converge to a half. Let's now look at another problem. So here we have the integral of 1 divided by x squared, and we're going from negative 3 to 3. Now, if you note, the integrand is not continuous at x is equal to 0. And as such, we have to split the integral up at this time. So, just take a note here. When x is equal to 0, we'll have 1 divided by 0. And we know that this means that this is not continuous. So, what we do is we separate our integral at 0. So, once again, that 0 there, that's the point that is giving us problems, right? That's a trouble point. So we integrate from negative 3 to 0, and then we go from 0 to 3. So we split our integral at that point where the integrand is not continuous. We now evaluate each of these individually. So evaluating the first integral, we have the limit as t tends to 0 from the left hand side. Now we're applying a similar approach as in the first question. So we replace our 0, so remember that's the point that's giving us a problem, right? So we replace that with the variable t, and we take the limit as t tends to 0 from the left. Now integrating here, we have the limit as t tends to 0 from the left of negative 1 over x. And of course, we are going from this guy here. This should actually be negative 3. So we're going from negative 3. So let me make that correction. So this should be negative 3. So we're going from negative 3 to t. Now substituting the boundaries, we have the limit as t tends to 0 from the left of 1 minus 1 divided by t. And applying our limit, so substituting t as 0, we have 1 minus 1 divided by 0. 1 divided by 0, that will give us infinity. So we have 1 minus infinity. And 1 minus infinity is equal to infinity. So that is undefined. So the integral diverges. So once we take the integral and we get it to be infinity, negative infinity, we say that the integral, I think this should actually be negative infinity. So it's 1 minus infinity, so it should be negative infinity. So whenever we take the integral and we get infinity or negative infinity, we say that the integral diverges. And since it diverges, since one part diverges, it means that the entire integral diverges. And as such, it means that there's no need for us to evaluate this integral. So we stop here and we say that the integral diverges. However, if after calculating this integral we got a finite number, then we'd have the need to calculate the other integral. So we'd have to calculate this integral. And if we get another finite number, we would add both, and that would be the integral. But since this is infinity, well, negative infinity, we can stop here because it tells us that the integral diverges.